Yeah. Good evening. How are you guys doing? Very good. Your doing good is needed because we are going to cover a rather conceptually challenging topic today. Slightly heavy in terms of concepts. Functions. I believe we had finished quadratic equations last time, right? Yeah. I guess we'd finished quadratic equations, yeah. And we will begin with, what do you call this? Functions today. We'll definitely finish functions. We will also, I talk about log a bit. Log is a function. And we'll probably take up inequalities in the next class. Okay. Then let's begin. I don't know why there are so few people today. The last class saw a fair number of people, but never mind. Okay, let's get started. I will share the earlier PPTs, Debashish. If you I have allowed everyone. No, I haven't. Yeah. Umesh, I've allowed you the permission to record. Debashish, you too. Please check. I will share all the earlier PPTs. Don't worry. Okay, let's begin. Yeah. Let's begin with functions. And if you remember, we had talked about quadratic function a lot last time. And quadratic function, if you remember, is something like this: y or fx, y equal to fx equal to ax square plus bx plus c. We're going to see a lot more functions today, but even before we talk about the different kind of functions, what we need to talk about is what functions really are. What is the sort of basic concept of functions? So functions is like this machine here in front of you that takes a certain input, a certain acceptable input, and gives a certain output. This, you could have taken this as, say, a washing machine. Function as a washing machine. You input dirty clothes and you get clean clothes out. Yeah? You can't input in a washing machine, you can't input bricks. You can't input bricks in a machine and in a washing machine and expect things to happen. Yeah. What I'm trying to say here is that there are certain limits to the inputs that you can put based on the function, and those limits define what we call the domain. The domain of the input, the domain of x, because we generally take the input to be x. So the values at which the function is defined, like in a washing machine, you can put clothes, but not, bricks, or in a juicer, you can probably put orange and reddish and so on and so forth, and carrot. You can put all that, but you can't put, say, I don't know, you can't put cheese in a juice. There are limitations of that machine. So that those limitations define the domain. All values acceptable, all acceptable input are the domain, and the corresponding output that you get, the values of fx possible, are the range. So that is a basic concept you need to understand with regard to a function. And we will talk a little more about this, taking function as a machine and talking about domain and range. And then we'll cover different types of functions. We will cover a couple of particular functions. We'll cover modulus function, greatest integer function, least integer function. We've already talked about quadratic function, but we'll also talk about categories of functions like composite functions, odd and even functions, and piecewise functions. So that is also something we'll cover. This is the broad agenda for functions today. And let me explain domain and range using these functions. Fx equal to 1 by x minus 1, fx equal to x square, and fx equal to 1 by 1 plus 3 root x. Now, if you look at this function, fx is equal to 1 by x minus 1. This fx or y equal to fx. So all acceptable values of I give the range, all acceptable values of x are the domain. We immediately know that fx equal to 1 by x minus 1, x is not equal to 1. Because at x equal to 1, you get 1 by 0, and 1 by 0 is not defined. So for the function, for the domain of the function, x is not equal to 1, but it can take any other real value. Yeah, we always, when you talk about domain, we always talk about domain in terms of the real values. Real values as in all values that are on the number line. On this number line that where values vary from minus infinity to plus infinity. Yeah, any value between minus infinity and plus infinity that lies on this number line is a real value. That is what real numbers are. Yeah, real numbers are numbers that lie on the number line. So if you look at this function 1 by x minus 1, other than x equal to 1, this function can take any other acceptable value. It is defined for all other acceptable values. X can be 10, x can be 10,000, x can be 50,000, 10 lakhs, 100,000 crores, x can be minus 20 lakh. It can take any other value. And therefore, we can say that the domain of this function, all the values of x that are acceptable, will be all values x belongs to, we write this as belongs to, x belongs to all real values except 1. R minus 1 is the domain of this function, which means all real values except 1. And similarly, if we talk about all values of y, the range of this function, the range of this function will be, since y is 1 by x minus 1, the denominator is x minus 1, which has to be a real number. Y is essentially equal to 1 by a real number. Yeah. 1 divided by a real number is never 0. This is not equal to 0, ever. And thus, just having a look at it, it can take any other value. You want y to be minus 10, put x to be, you can put y to be minus 10 and find the value of x. You will get a proper value of x. You want y to be 1000, you will find a proper value of x. It cannot be 0, and thus the range of y will be, y belongs to all real values. It can take any real value except 0. That is the range of y. Yeah, I hope this is clear. Let me explain, let me take a couple of other examples to make it absolutely clear here. So fx equal to 1 by x minus 1. For this, we saw that the domain is x belongs to all real numbers except 1. Y belongs to all real numbers except 0. Let's take another function, fx is equal to x square. Now, is this function defined for all real values of x? It is. X can take any value. There is no value at which it is not defined. Thus, x belongs to all real numbers. What about y? If fx is x square, if y is equal to x square, and x is a real number, we know for sure that x square is not negative. It cannot be negative. It can be 0 at the very least. If x is 0, then y is also 0. But thereafter, whether x is positive or negative, its value keeps on increasing. And in fact, if x is a very, very big number, infinitesimally big number, then y is also a very, very big number. Or even if f were to be a very, very small number, minus infinity, if it were to be minus infinity, y would still be a very, very big number. Thus the range of y will be, it can be 0 at x equal to 0, but it cannot be negative, it can only go from 0 to infinity. This is the range of y. Minimum value 0, maximum value very, very large, infinite. Let me take another example. Y is equal to 1 upon 1 plus 3 root x. You immediately realize, if you have a look at this function, x can't be negative. Yeah, x can't be negative, but x can be 0. X can surely be 0. So x will have to be all positive numbers. X will be equal to or belong to, it can be 0, but thereafter it has to be positive. It can vary from 0 to infinity, never be negative. But since it can be 0, if a number is included, we represent that using square brackets. If it's not included, curly brackets. This is just to establish common languages so that we are clear on what the question wants to say, or how we should represent this. So x can lie between 0 to infinity. What about y? If you look at y is again 1 divided by 1 plus 3 root x, which has to be a real number. Yeah. Y will be maximum when this real number is minimum. When the denominator is minimum, y will be maximum. It's absolutely clear. Which means 1 plus 3 root x. When this is minimum, y will be maximum. This will be minimum at x equal to 0. For sure. Yeah. If you put x equal to 0, the value of this is minimum and it is equal to 1. At at x equal to 0, the denominator is equal to 1. And therefore, the value of y will be 1 by 1, which is 1. That is the maximum value of y. And in terms of minimum value, if x becomes a very, very big number, infinitesimally big number, say 10 lakh to the power 10 crores, something of that sort, let's say, then the denominator will become a very big number. This real number will be very big and y will be very, very small. It will be close to 0. So y will keep approaching 0, it will never be 0. I've already said 1 by any real number, this is not equal to 0. It can be anything else. It can tend to 0. It can be very, very close to 0, but not actually 0. So the minimum value of y will be more than 0, not be 0. And at max, it can tend to 1. This must be my range. This is my range. This is domain. Let me know if this is clear. If these 3 examples are clear, or if you have a doubt in either of the 3 or in the concept in general, let me know. Is this clear, guys? Feel free to use a microphone or or chat. Umesh, is this clear? Very, very good. If this is clear, then let me throw some questions at you. There. Why don't you solve for questions from part 4 to 8? Yeah, please solve for domain and range, except in 4, find only domain. Just find domain. Range would become a headache for this. Find only domain of part 4 here. You can also obviously keep posting your answers on the chat window. I will neither confirm nor deny in the beginning. Keep posting it and I'll tell you later if they're correct or not. In part number 5, we've done a small formula for the minimum value of a quadratic function. 5 is a quadratic function, fx or y equal to x squared minus 6x plus 4. This is a quadratic function. We've done the minimum value. Its minimum value is always at x equal to minus b by 2. For a quadratic function ax squared plus bx plus c, the minimum value is at x equal to minus b by 2a. So you can use that to find the minimum value of 5. Part 5. Try these questions, please. Done, guys? Shall we discuss? Everyone, should we discuss? The others, shall we start discussing? Umesh, Abhishek, Devashish, I've already received answers from Abhishek. So Devashish, you haven't posted your answers. Of course, you need to post your answers before I start discussing. Please do post your answers, guys, on the chat window. Or use a microphone, of course.
Sir, I'm a little confused about fourth and fifth. But for sixth, it is domain is all real numbers, range is 0 to infinity.
Absolutely.
Seventh
For
is
sixth and seventh, domain is all real numbers,
and
and range is indeed 0 to infinity.
yeah, and for eight also it is domain is all real numbers and
Yeah,
range is 0 to infinity again.
absolutely. Range is 0 to infinity again. For 8, this is mod x. We will talk about in detail. We'll talk about mod x in detail. Um, for 4th, you only have to find the domain. And to find the domain, you have to ensure that the function is the range is different for, no, it is not. It is 0 to infinity. Range for 6, 7, 8 is 0 to infinity. All three is this.
Okay.
Yes. Abhishek has pointed out one important thing, and he's absolutely correct. And I think I just glossed that over. Apologies. The range here is slightly different in the sense that for 5 to the power x, um, for any for any such number whose base is not negative and non-zero, like 5 is not 5 is a positive number not equal to 0. 5 to the power x, 5 to raise to any power, this will never be 0. It will always be greater than 0. 5 to the power x will always be greater than 0. When x is a positive number, or when x is a large positive number, then 5 to the power x is greater than 1. Yeah. When x is a large negative number, then it becomes say x is minus 1000, then 5 to the power minus 1000 becomes 1 by 5 to the power 1000. It becomes a very small number, but it still remains greater than 0. However, so for this holds for both 5 to the power x and 5 to the power minus x. Their domain and range is exactly the same. There's hardly any difference. For fx equal to mod of x, the domain is all real numbers, but the range includes 0. That's the only difference. In the two above, 6 and 7, 0 is not included. Yeah, and thus you have this curly bracket. And in mod x, 0 is included because x is equal to 0 is defined. You can put x equal to 0, you find fx or y equal to 0, and thus there's a small difference. Very important and rightfully pointed out by Abhishek. Good, Abhishek, well done. And fx equal to x square minus 4x, 6x plus 4. Let me see the other answers. It is indeed minus 5 to infinity. Good. The range of 5, the domain of 5 is x belongs to all real numbers. X can take any real value. It's clearly not defined any value. The problem with y is, and as I had said, if you remember, y is minimum. So this x square minus 6x plus 4, now I'm going back to the last class. Here, the coefficient of x square is a positive coefficient. It's greater than 0. The coefficient here is 1. Thus, the graph will be of this sort, this kind of graph. Opens upwards, U. Yeah, and it will have a minimum. This graph will have a minimum, its maximum will be infinity. So in terms of range, y can be as much as infinity. You know, it can be a very big number, but it has a minimum, and its minimum, y's minimum is at x equal to minus b by 2a. So at x equal to minus of minus 6 by 2, at x equal to 3, this will have its minimum. And at x equal to 3, the minimum is minus 5. So this is the sort of range of y. Devashish, I hope that is clear. At x equal to minus of b by 2, a minus of minus 6 by 2 into 1, which is 2, 6 by 2, x equal to 3. The value of y is minimum. Put x equal to 3 in this function, and you get y is equal to minus 5. This is the minimum value. The reason x equal to 3 gives the minimum value is because this quadratic function x square minus 6x plus 4 can be represented as x minus 3 whole square minus 5. If you complete the whole square of this x square minus 6x, you can complete it as x square minus 6x plus 9 minus 5. 4 can be written as plus 9 minus 5. And this portion, x square minus 6x plus 9, this is x minus 3 whole square. And therefore, of course, we know x minus 3 whole square. The minimum value of this expression, without a shadow of doubt, is 0 at x equal to 3. It can never be less than 0. So to get y minimum, you minimize x minus 3 whole square, which means you keep it to 0. And the minimum value of y comes out to be minus 5. Okay. For fourth. Fx is equal to under root of x plus 7 is under root of 1 minus 5x. You have to ensure, you only have to find the domain here. To find the domain, you have to ensure both under roots are defined. That's all you need to do. Define both under root values, which means the first under root is defined, under root of x plus 7 is defined if x is greater than or equal to minus 7. And the second under root, 1 minus 5x is defined if 1 minus 5x is greater than 0, which means x is less than or equal to 1 by 5. Yeah, you must ensure this is 0 or more. So 1 minus 5x will have to be greater than or equal to 0, which will give you x less than 1 by 5. And similarly, x plus 7 has to be greater than or equal to 0. That will give you x is greater than minus 7. This is your range. This is your domain here. X must be less than 1 by 5, less than 0.2, less than or equal to 0.2, while being greater than or equal to minus 7. This is my domain. All values of x between these two values will be acceptable, and outside them not acceptable. This is my domain. I hope this is clear, guys. Let me know if there's an issue in either of the questions, in any of the questions. Very good. Okay, then let's talk about, before we jump to modulus and greatest integer functions, let's talk about the different categories of functions. So there's something called composite functions, odd and even functions, and piecewise and series functions. This is, these are not terms you'll see on GMAT directly, but they're sort of my way or our way of explaining different functions. And composite functions essentially, let's start with composite functions. So I hope right now, I hope this is what is clear when I talk about fx equal to 2x minus 1. I hope this is clear that x is the input and 2x minus 1 is the output. Yeah. So essentially, function f, the nature of function f is that it multiplies the input by 2 and subtracts 1. That is what fx equal to 2x minus 1 means. that the output you get is twice input minus 1. Or if gx is equal to x squared plus 3, it means g as a function is, it squares my input and adds 3 to this square. Yeah. So, we have been talking about inputs. This is what f and g represent. So if you input x here, you will get 2x minus 1. If you input something else, you will get twice of that minus 1. For example, f of gx. F of gx simply means that the input is gx, which means since we said function f is what? Twice of input minus 1. Then f of gx will be twice of gx minus 1. So that means it will be twice of gx is to x squared plus 3. So twice of x squared plus 3 minus 1. That is what f of gx is. It's also read as f o gx. F of gx is also read as f o gx. And g of fx means g as a function was nothing but input square plus 3. So g of fx would mean input fx whole square plus 3. Fx we know was 2x minus 1. So 2x minus 1 whole square plus 3. That is g of fx. This is what composite function is. Really simple, really basic. There's nothing exceptional or very difficult conceptually about composite functions. Yeah. So if I had to find f of g3, this would mean finding f of g3. So what you can do is you can find g3 first and then use that as an input. So you can find g3. G3 comes out to be 3 square plus 3, 9 plus 3, 12. So you basically are trying to find out f of 12, which means putting x equal to 12, which would mean twice of 12, 24 minus 1, 23. So f of g3 is 23. G of f minus 2 would mean finding g of f minus 2. F of minus 2 would mean 2 into minus 2, minus 4 minus 1, minus 5. So g of minus 5. F of minus 2 is minus 5, so you have to find g of minus 5. G of minus 5 is minus 5 whole square plus 3, 25 plus 3, 28. I hope this is clear, guys. Let me know if you have any doubt here. Okay, good. Odd and even functions. What are odd and even functions? Very simple definition again for odd and even functions. Whenever fx is equal to f of minus x, which means that the output of the function, if you take a certain value, and the output, if you take the exact negative of that value, remains the same. For example, for x square, for fx equal to x square, whether you take x equal to 3 or minus 3, the output remains 9. Plus 3 square is also 9, minus 3 square is also 9. Yeah, so x square is surely an even function. This is even. Since whatever value you take, the output of the negative value is also the same. Or fx equal to mod of x. Whether you take x to be plus minus 3 or plus minus 10, whatever value you take here, the output remains the same. Yeah. Or this a to the power x plus a to the power minus x. For example, this could have been 5 to the power x plus 5 to the power minus x. So this is my function. If you take x equal to 2, then the function becomes at f of 2, the function becomes 5 square plus 5 to the power minus 2, which is also equal to f of minus 2. At f of minus 2, the value remains 5 to the power minus of minus 2, 5 square, plus 5 to the power minus 2 is the same value. x and minus x sort of interchange, when you take negative. So all these functions are even functions. Mod x, x squared, x to the power 4. This is not x, x to the power 4. A to the power x plus a to the power minus x. These are all even functions. In odd functions, the sign changes. So f of minus x is equal to minus of fx, which means if you take x to be negative, the sign of the whole function changes. For example, fx equal to x. If you take x to be 3, then the output of the function is 3. If you take x to be minus 3, the output is exactly the negative. Or for x cube, or for a to the power x minus a to the power minus x. Here again, if you, for whatever x you take, taking the negative value will change the whole function. It will be the exact negative. So if fx is equal to a to the power x minus a to the power minus x, so say you take f of 2. If you take f of 2, you get a square minus a to the power minus 2. If you take f of minus 2, you get a to the power minus 2 minus a to the power minus 2 a square. These two are exact negatives of each other. This is a square minus a to the power minus 2. This is ulta, the exact and opposite. A to the power minus 2 minus a square. Surely it's absolutely clear that f of 2 is minus of f of minus 2. You could also have said that this is also a very important way of putting odd functions, that fx plus f of minus x comes out to be 0. If I add 2 and f of minus 2 here, I'll get some 0, which is absolutely clear. A square and minus a square will cancel out. A to the power minus 2 and minus a to the power minus 2 will cancel out. So this is how we generally see odd functions. What is important, in both, the value remains the same. You get odd and even functions. Function is odd or even. If the value is remaining the same, if you change x to minus x, but the sign has changed. For for an odd function, the sign changes. For even, it doesn't. And of course, in a function in which the value doesn't remain the same, it's neither even nor odd. Many examples for fx equal to x minus 2 whole square. If you put x equal to 2, then fx is 0. If you put x equal to minus 2, then fx is 16. The value is not the same. F of 2 is 0. F of minus 2 is 16. Clearly not an even or an odd function. Yeah. So this is something you should note and remember. And finally, a piecewise or a series function. Series functions are different. A piecewise function is a one in which these functions have different output for different domains in X. So a function may be defined in a way, that when X is less than or equal to minus 2, fx is equal to x plus 4. For X between minus 2 and 8, fx is equal to 2. For X greater than or equal to 8, fx is 3x minus 22. Yeah, you can even plot this function. You can try to plot this function, y equal to x minus 4, 2, and 3x minus 22 for these different ranges. You will find that the function is something like this. I didn't understand your question, Archer. Fx equal to 0 simply means that the function is intersecting the x-axis at a certain point. Whenever the function intersects the x-axis, at that point, fx is equal to 0. Yeah, so saying that it's an odd, either odd or even, you can't say. You don't have enough information. Okay. So this function, if you had to sort of plot this function on the xy axis, this would be something like x increases, y also increases, x plus 4. Yeah. Something of this sort. This is x equal to -2. This is x equal to 8, let's say. So here the function is x plus 4, y is equal to x plus 4. Here the function is y is equal to 2. And here the function is y is equal to 3x minus 22. So this is the piecewise function. Different outputs for different values of x. Different outputs for different domains of x. Yeah. A classic example of piecewise function follows next. And it is the modulus function. The modulus function is piecewise in the sense that fx, the modulus function, is equal to x when x is greater than 0, and it is equal to minus x when x is less than 0. For x greater than 0, fx or y is equal to x. This line is y is equal to x. And when x is less than 0, then y is equal to minus x. This is the line. So that ensures, if x is negative and the output is minus of that negative number, then y remains positive. Which is why modulus x, fx equal to mod of x, it never goes below the x-axis. It's always positive. So, and this is very important. You should remember this. We're done that fx equal to mod x. The range of this function is 0 to infinity. And the graph may make it absolutely clear. This is 0, y equal to 0. And of course, this keeps on increasing. It can go up to infinity, up to a very big number. Let's talk about this. Mod of x plus 4 equal to 6. So say this is this. I can see this as a certain function y is equal to mod of x plus 4, and it is equal to 6. Y is equal to 6. What does this tell me about x? Mod of x plus 4 is equal to 6. Now, what we know about x is, what you know about fx, y is equal to mod x was that y is either equal to x or equal to minus x. Y is either equal to x or minus x, which means x plus 4 is either equal to 6 or x plus 4 is equal to minus 6. This is the only way of conceptually solving mod of x plus 4 equal to 6. X plus 4 is either 6 or x plus 4 is minus 6. That gives you two values. X is equal to 2 or x is equal to minus 10. Yeah, so solving mod of x plus 4 equal to 6 will give you these two solutions, 2 or minus 10. Is this clear? I've covered a lot in the past 10 minutes, some basic important concepts. Is this clear, guys?
Sir, how will we plot example 1 on graph?
Sorry?
So how we will plot example 1 in modulus of x plus 4 is equal to 6?
Modulus of x plus 4 equal to 6 is not a graph. This is a value. It's an equation. We could have plotted fx equal to x, mod of x plus 4. Yeah? And this is exactly similar to mod of x. Fx equal to mod of x was like this, right? Meets at the origin. The only difference between fx equal to mod of x and fx equal to mod of x plus 4 is that y is 0 at x equal to minus 4. So this graph kind of shifts a bit. If this is my y-axis, this graph will shift a bit. That is all. It will become 0 at x equal to minus 4. Otherwise, the shape will be exactly the same. It's exactly the same graph.
Hello, Abhishek.
Hello?
Hi, it's Abhishek Rahul here. Hi, Abhishek.
Go ahead.
Yeah, I just have a small question. Can you please go back to the slides where we have defined odd and even functions?
Okay.
I have a small question over there.
Okay. You know what I would appreciate, Abhishek?
Yeah.
Would you prefer if I call you Rahul? I think there are too many Abhisheks around.
Yeah, fine. Yep.
Yeah. Rahul, if you have problem in a particular topic, feel free to ask it immediately. You can send me a text in the chat, or you can use the microphone. There is no issue.
Yeah. Just can you please? I understood in which cases even and odd function can be even and function can be odd. In which cases, like what are these two notes at the bottom of the slide? What does these two signify?
So note number 1 means that for both odd and even functions, the value of the function remains the same. It's the sign. So what I want to say here is, for either odd or even function, the value of fx and the value of f of minus x, it will be the same, but the sign may change.
Okay.
I can also put this as that for both odd and even functions, mod of fx is equal to mod of f of minus x. Yeah. So their sign may be different. For odd function, the sign would be exactly the opposite. For an odd function, f of 3 would be equal to minus of f of minus 3. This is for an odd function. Okay. For an even function, they would be exactly the same. F of 3 would be equal to f of minus 3. But surely, in either case, in either odd or even function, the magnitude is the same. Yeah.
Yeah.
So that is what I meant here. In other functions, the magnitude won't be the same. That's the main difference between odd even functions and other functions, and functions that are not odd or even.
Okay.
Yeah. Do you want to take examples of other functions?
Yeah, please do.
Okay. So the one I had taken was x minus 2 whole square. This is neither odd nor even, because you can take some value of x. Let's take fx equal to 5. Let's take f of 5. Let's take x equal to 5. And let's take x equal to minus 5 once. At x equal to 5, or at f5, the value of the function is 5 minus 2, 3 whole square, 9. At x equal to minus 5, the value of the function is minus 5 minus 2 minus 7 whole square, which is 49. Their magnitude is different. One is 9, the other is 49. So there is no question of this function being either odd or even.
Got it.
Yeah?
Yeah.
Okay, cool.
Just one more request. I joined a bit later. Can you move the slides up so that at least I have these in recordings?
Sure. I generally give these slides as a PDF at the end of the class.
Okay, so because I don't know, last class we didn't get it, so I thought
I think I had some problem last Saturday. I think we didn't have the chat window, if you remember.
Yeah.
We do have the chat window today, so I will be able to share the documents.
Okay, thanks. Yeah. So would you send the
previous
PPT from the last one also?
I will. Yes, of course.
Yeah. Then fine enough. Thanks, Abhishek.
Yeah. Okay, cool. Then let's move ahead to, we were at modulus function. Yeah, so you're talking about this x plus 4 equal to 6. Let me just quickly plug my charger. 1 second, guys. I'll be back in. It's closing. Guys, am I audible? Hello guys, am I audible? Okay, cool. Sorry about the snag. Okay, then let's start from where we ended what we were discussing. So yeah, we were discussing mod of x as a function. So mod of x, we discussed this. Mod of x plus 4 equal to 6 means, you should remember, x plus 4 is either equal to 6 or x plus 4 is equal to minus 6. It cannot mean anything else. Yeah. How do we solve this? Mod of x minus 1 plus mod of x minus 2 is equal to 9. Now, the best way of solving this is understanding that mod of x minus 1, mod of x minus 1, this will be equal to x minus 1 if x minus 1 is greater than 0, which means if x is greater than 1. And this will be equal to minus of x minus 1 if x is less than 1. If x is less than 1, then this becomes negative, then x minus 1 becomes negative, then mod of x minus 1 becomes minus of that negative number. Mod is always positive. The output in mod is always positive. Yeah. So 1 is very important as a value for mod of x minus 1. And similarly for mod of x minus 2, x equal to 2 is a very important value. Just like 1 was a very important value for mod of x minus 1. The reason why I'm saying all this is because this question 2 can be solved using the number line. Mark 1, mark 2 here. Now we know what we know about x minus 1. And what we know about x minus 2 we'll use here. We know that when x is less than 1, both these are negative. X minus 1 is negative as well as x minus 2 is negative. For x lying between 1 and 2, yeah, say x is 1.5. If x is 1.5, this is positive. Mod of x minus 1 is positive, but mod of x minus 2 is negative. Yeah, but for x greater than 2, say 5, both are positive. So essentially, you have to divide this expression into 3 ranges and check at the 3 ranges. Which means I'll firstly take if x is less than 1. If x is less than 1, both of them are negative, which means mod of x minus 1 will become minus of x minus 1. Mod of x minus 2 will become minus of x minus 2. So mod of x minus 1 plus mod of x minus 2 becomes minus x minus 1 minus x minus 2 is equal to 9. Solve. Now you need to solve. You have to solve this and check if the value of x, if the value that you get of x, is it actually less than 1? It has to be less than 1. If it is not less than 1, if it comes out to be greater than 1 or equal to 1, then the solution is not acceptable. For example, here, if you solve this, you get minus x minus 2x is equal to minus of minus 1 plus 1, minus of minus 2 plus 2 is equal to 9. This is 3. This comes out to be minus 2x is equal to 6. X is equal to minus 3. So, is x equal to minus 3 less than x equal to 1? Yes, it is. Therefore, this is an acceptable solution. X equal to minus 3 is acceptable. The next region we have is x lies between 1 and 2, x greater than 1, less than 2. And in such a scenario, when x is greater than 1, then this is positive. Mod of x minus 1 becomes x minus 1. Mod of x minus 2 becomes minus of x minus 2. This comes out to be x minus x and minus x. X cancels out, and you get minus 1 plus minus 1. Minus of minus 2 is plus 2. Minus 1 plus 2 is 1. So you directly get this sum to be 1. Clearly 1 is not equal to 9. And thus, if left hand side and right hand side are not equal, it means that this assumption is invalid. Then x does not lie between 1 and 2. No solution of x lies between 1 and 2. It is absolutely clear. Yeah, and the third scenario is if x is greater than 2. Here, both are positive. If x is greater than 2, this is positive, which means mod can be ignored. Mod of x minus 1 becomes x minus 1. Mod of x minus 2 becomes x minus 2. This is equal to 9. If you sum this up, this becomes 2x minus 3 equal to 9, 2x equal to 12, x is equal to 6. Is x equal to 6, is x greater than 2? X equal to 6 greater than 2? Yes, it is. Acceptable? Yes. If it does not violate our initial constraint, our initial assumption, then it's a reasonable solution. Thus, we have two reasonable solutions for this equation. X is equal to minus 3 and x is equal to, or x equal to 6. Yeah, we always say or, it's not and. It's x equal to minus 3 or x is equal to 6. X only takes one value at one point. It cannot take two values at the same time. Is this clear, guys? Guys, is this clear? Am I audible?
Yes, sir, you're audible. It's clear, but we can't reply on the chat.
Why?
It says Edushastra team is not in the meeting.
That is funny. That is very funny. I am here in the meeting. Can you try now? Why don't you try now? Because I did receive Devashi's reply. So I'm very surprised
No,
that
sir, still it says Edushastra team is not in this meeting.
Sir, I think when you went offline at that time, I think he has to change, Abhishek has to change the drop down over there and then reply.
okay.
I'm stuck with privately reply, you know, I cannot change it.
Yeah.
No,
even
but
I
that's
cannot.
okay. So that's a change the setting. We have changed the chat settings to private only, but that doesn't mean that you can't reply. You can still reply to me. You can send me messages. I mean, the others
No.
won't see it, but I should get, as in.
No, Abhishek, I'm not able to send you anything. It's
Okay,
same
that's it. So this, for some reason, you know, the Saturday evening online batch is hallowed in that sense, because I just received Devshi's message. I have not received any other message. And this hasn't happened before. What happened last week has never happened before in any other batch. And what has happened right now has also never happened before. There's never been any problem with chat. So I don't know what to do about it, because there clearly is, and this is probably a Zoom snag, because Devashish did just send me a checking message, but I've not received any message from anyone else. So, okay, I guess that means that I would appreciate if you can use microphones more regularly to reply, so that we can move ahead. You know, otherwise there's no way I will get to know whether you are on track, whether you are with me, or whether you have some issue in the concept. So let me know with regard to question number 2. Is this clear? Is this method clear? Mod of x minus 1 plus mod of x minus 2 is equal to 9. Did you understand that you can get two solutions, minus 3 and 6? Is this clear, guys?
Yes.
Okay, again, I just received a message from Devashish. Yes, but I did not receive. Okay, so I don't know what the issue is. Okay, then I want you to try this. If you understood what you've just done, so Archak is also able to send me messages. Good. I think it's only an issue with the two Abhisheks, Garg and Rahul. I don't know. I'm wondering if Umesh can also send me messages, because Devashish and Archak have been able to. So. Okay, let me give you a couple of simple questions. Can you find out this value of this mod of x minus 4 plus mod of x plus 1 is equal to 27. Solve for x. You have to solve for x. Mod of x minus 4 plus mod of x plus 1 is equal to 27. This is one question, and a slightly difficult question. Please start with that question. I'll give you the other one in a minute. Please try these two questions, guys. Mod of x minus 5 plus 2x plus 4 equal to 17. If you're not able to solve
minus 12 and 15.
You can put it here as well. Is it minus 12, 16?
Minus 12 and 15.
Possibly. Yeah. Try the next one. Try the second one. I'm not sure if the others even started when you gave the answer. I guess you must have done a hit and trial, which is good. You can always do a hit and trial. You should always do a hit and trial. Take a couple of minutes, guys, and then you move ahead.
Answer for the second question, minus 16 by 3 and 6.
Done, guys? Done the 2 questions? Have you done the 2 questions?
Yes.
Okay, what are the answers to the first one?
15 and minus 12.
Yes, 15 and minus 12 is absolutely correct. It's actually, you know, we should not technically, this is either 15 or minus 12. X takes one value at one time. So it's either 15 or minus 12. This is an important distinction because in a DS question, if this came as a DS question, what is the value of X? And this expression was given to you, then you would have 2 values of X. It's either 15 or minus 12. You would not have a distinct value. That is something you should remember. These are 2 different values, and they're not. I mean, X is not 15 and minus 12 at the same time at 2 different instances, sort of. So that's something you can remember, guys. And question number 2. Any values for question number 2?
Minus 16 by 3 and 6.
Minus 16 by 3 and 6. Possibly. Minus 16 by 3. It is definitely 6. Okay, I'll take your word for minus 16 by 3 as well. Yeah, it is. It is. Minus 16 by 3 and 6 are absolutely correct. Guys, problems in which questions? Let me know. Which questions do you have a problem in? Let's discuss this. Any problem in any of the questions? Please remember the chat is not working for some of you, so feel free to use the microphone. Okay, no problem in either of the questions. Yeah, here in question 1, when x is less than minus 1, both are negative. So you will use mod of x minus or mod of x plus 1 as minus of x plus 1, and mod of x minus 4 as minus of x plus 4. Between minus 1 and 4, x minus 4 remains negative. It remains minus of x plus 4, minus of x minus 4, sorry. But x plus 1 becomes positive, so it becomes x plus 1. And when x is greater than 4, both are positive. It becomes x plus 1 and x minus 4. So, you know, in these 3 sort of, in these 3 domains, different domains, you have to take these 3 different functions, equate them to 27 and find out which ones give you solution. There is no solution for the one in the middle. There is a solution when both are negative, and there is a solution when both are positive. And similarly, in question 2 below, 2x plus 4 becomes negative at x equal to minus 2. It becomes 0 at x equal to minus 2. So whenever x is less than minus 2, 2x plus 4 is negative. So it's negative here. And x minus 5 is negative when x is less than 5. So, you know, x minus 5 remains negative till x is less than 5. Thereafter, it's positive. And 2x plus 4 is negative when x is less than minus 2. Otherwise, it's positive. So even for this, I don't think there is a solution. I think there is a solution. There is a solution here for sure. There is a solution here for sure. Is there a solution in the middle? I think there is a solution in the middle. Because you get minus x plus 5 plus 2x plus 4. So x plus 9 is equal to 70. No, you don't. You get x equal to 8, which is not. Yeah. Yeah. So these are the only 2 values, correct 2 values. There's no solution in the middle because if you solve, you take x mod of x minus 5 as minus of x minus 5, which is minus of x plus 5. You take mod of 2x plus 4 as 2x plus 4. If you add them up, you get 2x minus x plus 5 plus 4 plus 9 is equal to 17, x equal to 8. But that is not an acceptable solution because in your range, x lied between minus 2 and x lay between minus 2 and 5. Your solution must reflect that. X has to lie between minus 2 and 5. It cannot be more than 5 or less than minus 2. And it is here. X equal to 8 is not acceptable. And thus you do not again have a solution for the range in the middle. I hope this is clear, guys. I hope there is no issue with these questions. Okay, cool. This we'll discuss. Example number 3, we will discuss once we study inequalities. We'll study inequalities in the next class. We'll take this up thereafter. But this is important. Let's jump on to the next function, greatest integer function. So greatest integer function, the definition of greatest integer function is that the greatest integer value of your number, whatever that number is, it is equal to the greatest integer that is less than or equal to the number in the middle. So when, for example, greatest integer value of 3.7 would mean, if you were to locate 3.7 on the number line, this is where 3.7 is, then greatest integer of 3.7 would either lie on 3.7 or to the left of it. And it can lie on that number if that number is an integer. The output of the greatest integer function is always an integer. Yeah, and it either is equal to the number if the number is an integer. If not, it is the closest integer it's the first integer on the left of the number with respect to the number line. So greatest integer value of 3.7 is 3 because from 3.7, if you go to the left, the first integer you encounter is 3. Similarly, greatest integer value of minus 4.3 is not minus 4, it is minus 5. Because on the number line, starting from minus 4.3 is not an integer. The first integer on the left is minus 5. Yeah. However, greatest integer value of 2 remains 2, since 2 is an integer. Greatest integer value of minus 3 is also equal to minus 3. The greatest integer value of an integer is the same integer. But for others, it is the closest integer on the left. Is this clear, guys? Similarly, there's also something called the least integer function. The least integer function is greater than or equal to x. So the greatest integer function was the closest integer on the left. The least integer function is an integer. It is the closest integer on the right. Closest integer on the integer or to the right. On or to the right of the number. So it's denoted by reverse square brackets. Greatest integer is generally denoted by square brackets. And reverse of this is least integer function. So least integer value of 3.7 will be equal to 4. Again, we locate 3.7 on the number line. The first integer on the right is 4. Similarly, least integer value of minus 4.4 is minus 4. But the least integer value of 2 and minus 3 remain 2 and minus 3. Because 2 and minus 3 are integers. I hope this is clear, guys. Yeah, is this clear? I appreciate an answer.
Yeah, it's clear.
Okay, very good. Don't know what the others are doing. Okay, very good. Thank you. Then let me just ask you these questions. Some good questions here. We've already done one. So we're going to attempt one. Please try the other 4. This here is, sorry, in question 4 and 5, the square bracket represents the greatest integer function. And of course, in question 2, your mod. This is mod of 5x plus 2 and mod of y plus 1. Please try these 4 questions, guys. In about 6 minutes max. You don't need more than that. Please take about 6 minutes maximum to try these 4 questions.
Second is minus 1 by 25.
Sorry?
Second is minus 1 by 25.
No. Second is not minus 1 by 25, I'm afraid. So, you know, the way you can minimize, the way you can find the least value of x by y is to make one of them negative and one of them positive. So the way it could generally work is maximize x, maximum possible value of positive value of x, and the negative value
Minus
of
1 by 3.
Or the other. Minus 1 by 3 is the right answer, yes.
Sir, in second question, if x is equal to 1 by 5 and y is equal to minus 5, that
If x is equal to 1 by 5
and y is equal to minus 1 by 5,
hmm,
that gives us minus 1 by 25.
there are other values as well, right?
Yeah, the other one is x is equal to minus 1 and y is equal to 3.
So yeah, so is minus 1 by 3 less or minus 1 by 25 less?
I got it.
Yeah, I think I would need to discuss most of these questions. But yeah, I mean, you got 2 answers. You can compare the 2 and find out which one of them is less. Surely minus 1 by 3 is less than minus 1 by 25. Yeah,
So for the third one, I think the domain will be all real numbers, and the range will be from minus 3 to infinity, inclusive of minus 3.
Minus 3 to infinity, inclusive of minus 3. That is correct. Yes.
And for the fourth one, I think the answer should be 61.
I'm sorry, I'm going to hold you here. Arjun, sorry. If you solved them good, keep them. If you solved all of them, have you?
No, so the last one is
Then
left.
keep them with you, or share them on the chat window. I will share the answer key screen, in a couple of minutes. But I wouldn't want you to influence the others. Let them take a couple of minutes to solve on their own. Yeah. So once you can finish, you can check with me through the chat window. The chat window is available too. I'll let you know if any of your answers is incorrect. Last couple of minutes, guys. Max, please.
So are my answers correct?
You should check your answer to question number 5, Archak, and question number 4. Let me check for question 4. You should also check for question 4. Yeah, unfortunately. Check for 4 as well. You have to get the maximum value of x plus y. You may have found the minimum value. What you have found is the minimum value, Acha. Minus 61 is going to be the minimum value of x plus y. If x and y are both natural numbers.
Fifth answer is 21.
No, it's not 21. And time is up. Let's discuss. Let's discuss the questions.
So the fifth is 13.
5 is 13. Absolutely correct. Any other answers, guys? Here are the answers. Have a look. Okay, let's discuss. Any problem with question 2? Any problem with question 2, guys?
No, sir.
The others, let me know if anyone else has a problem.
No.
Okay, good. Question 3, any problem? Domain is
No, sir.
all real numbers, range is -3 to infinity.
Abhishek,
Yeah.
I just have a request here because I joined a bit later. I missed that part of domain and range. Can you please explain this one?
Okay, I will explain this one. I'll explain both 2 and 3 because Devashish also has a problem in question 2. Let me start with 3 first. For any function fx equal to x square minus 4x plus 1, for any function, domain is the values or the set of values for which this function is defined. So at which all values of x can this function be defined? Or in other words, is there a value of x, is there a real value of x for which this function is not defined? Actually, there is no such value where the function is not defined. X can take any real value. And by real value, we mean real numbers are all numbers or their numbers that lie on this number line that lie between minus infinity and plus infinity. They can take integral values, they can take decimal values, they can take whichever values they want. Yeah, so there is no issue taking any real value of x here. So the domain of fx of this function is x belongs to all real numbers. X can take any real value. But range, we put y equal to x square minus 4x plus 1. For any of these real values, what could be the possible range of y? What could be the range of the output? Now, in a quadratic function, there are limits to range. And if you remember, last time we had discussed for any quadratic function, ax square plus bx plus c, the minimum value of this, of y or fx, whatever you want to put here, is you get minimum value at x is equal to minus b by 2a. Yeah.
Yeah.
So minimum value will be at, y minimum will be at, for this function, x equal to minus of minus 4 by 2 into 1 by 2. Minus of minus 4 is 4 by 2 is 2. At x equal to 2, you get the minimum value of this function. So put x equal to 2 here and check what the value is coming out to be. At x equal to 2, the value is coming out to be minus 3.
Yeah.
Yeah, so y minimum is surely equal to minus 3.
Okay, got it. Thanks.
And its maximum value will be infinity. Because if you remember, we had discussed this last time, for a quadratic function whose coefficient of x square is positive, the coefficient of x square here is 1. All such functions open upwards. They have this U shape.
Yep.
And for a greater than 0, for coefficient of x square positive, this is the shape. And thus you have a minima, but you don't have a maxima. The maxima is infinity. They'll just keep on going. Yeah.
Yeah.
So the range of this function is 3, inclusive of 3. 3 is possible to infinity. I hope this is clear, Rahul. I think I did discuss.
Yeah, it's clear. It's clear. Thanks.
Question number 2. What do we do about question number 2? We have to find out the least value of x by y. Firstly, if you want to find out the least value, ensure that at least one of x or y is negative, because then you have a negative value. A negative value is always less than a positive value. So if you check x here, mod of 5x plus 2 equal to 3 can only mean one thing, that 5x plus 2 is either equal to 3 or it's equal to minus 3. Which gives me two values of x. One of the values is 1 by 5. The other value is minus 1. Similarly, mod of y plus 1 is equal to 4 can only mean one thing. Y is either equal to 3 or y is equal to minus 5. Yeah. You should take this combination, x positive, y negative, or x negative, y positive, to find the least value. So in the first combo, x is 1 by 5 and y is minus 1 by y is minus 5. Then x by y becomes 1 by 5 divided by minus 5, which becomes minus 1 by 25. And in the other value, x by y becomes minus 1 divided by 3. Surely minus 1 divided by 3 is less than minus 1 by 25. The value that is less, two numbers, if you compare two numbers, the one that is less is more to the left of the other. Minus 1 by 25 is minus 0.04. Minus 1 by 3 is minus 0.33. Surely this value is to the left of the first value. And this is the least possible number. I hope that is clear, Devashish. Okay, excellent. What about question number 4? If root x is equal to 5 and root y is equal to 6, and x and y are both natural numbers, then what is the maximum value of x plus y? Please understand this. If root x, the greatest integer root x is equal to 5, it means that root x can be 5, root x itself can be 5, or it will have to be just less than 6. Root x can't be equal to 6. If root x were to be 6, then greatest integer of 6 would be 6, right? Root x can be just less than 6. In fact, I mean, in terms of value of root x at max could have been 5.9999. It could have been 5.9 bar. That could have been the maximum possible value of root x. Now, what does that tell us about x? That tells us, if I square, everything here, it tells us that x can be equal to 25. Under root of 25 is 5. But it cannot be 36. It has to be less than 36. X equal to 36 here would have given the root of 36 as 6 and greatest integer of 6 as 6, of course. So x has to be less than 36. What can be the maximum value of x? X can be at max 35. This must be the maximum value of x. Because once you take under root of 35, you get 5 point something. And greatest integer of 5 point something is surely 5. So x at maximum can be 35. And in a very similar fashion, y, since root of y is equal to 6, it means that root of y can be greater than or equal to 6, but less than 7. Cannot be 7. Which means y must be less than 49, but it can be greater than or equal to 36. And being a natural number, the maximum value of y can be equal to 48. So x max or x plus y maximum will be when you add the maximum value of y to the maximum value of x, which will give you 83. 48 plus 35, 83. Is this clear? Is this clear, guys?
Yes.
Okay. Did anyone have a problem with question number 5? Any problem with question 5, guys?
No, sir.
Yes, sir.
Do you have a problem, Rahul? Sorry.
Yeah. Can you please explain?
Why not? Sure, I will explain. In 5, all these square brackets are greatest integer values. Now, what is the greatest integer value of 0.1? It is the greatest integer to the left of 0.1, which is 0. Similarly, greatest integer value of 0.1 plus 0.2, which is 0.3, this is also 0. Of 0.1 plus 0.2 plus 0.3, this is 0.6, this is also 0. But here, 0.1 plus 0.2 plus 0.3 plus 0.4, this is 1. The sum of this is 1. Greatest integer of 1 is equal to 1. Thereafter, greatest integer value of 0.1 up to 0.5, this becomes greatest integer value of 1.5. This is 1 again. Greatest integer value up to 0.6 is 1.5 plus 0.6. Greatest integer of 2.1. This is 2. Add 0.7 also to the mix, and you get greatest integer of 2.8, which is 2. Add 0.8, and you get greatest integer of 3.6, which is 3. Add 0.9, and you get 4.5, which is 4. All you need to do is add all these numbers.
Yeah.
So 1 plus 1, 2 plus 2, 4 plus 2, 6 plus 3, 9 plus 4, 13. 13 must be the sum of these of this expression. I hope this is clear.
Yeah. Thanks.
Okay. Any other problem, guys, in what we've discussed so far? Let me know.